I'm here to give you all a speech today about what we do here at B&H Extrusion Dies and Tooling. My name is Matt Buchanan. I've worked here for 14 years and I've done just about everything. So I guess if I can get y'all's names.
My name is Marco.
Hey Marco.
Luis.
Andre. Andre. So before we begin, I guess, do you all have any questions?
What are these dies used for?
Well, let's just go ahead and get started into the process. So what is a die? This is a die. There are many different kinds of dies. It's cut in half just for educational purposes. This is an aerospace die. Aerospace meaning planes, and that's pretty much like the backbone of an aircraft. But dies come in many different shapes and sizes and weights, as y'all have seen out there. And then we have, what do we have? We have at least 8 customers that I know of that order. We put out, what, 250 a month at least. So these are made out of solid steel. And here's a little bit of description. The aluminum extrusion dies are used to manufacture specific shapes at exact dimensions to produce an aluminum extrusion. A die is what we at B&H manufacture. There are many different types of dies. There's food dies, there's vinyl dies, there's plastic dies, there's all kinds of molding dies. I mean, it's just amazing, but we focus here on aluminum dies. These dies come in all shapes, sizes, and hardnesses, as I said before, and also prices. A die is a type of mold in which is used to produce the same shaped product until the die has been worn out. The process is complicated down to the decimal point. As y'all have seen, we go by thousandths. Aluminum extrusion presses are massive machines, and you'll see at the end of this presentation some pictures of them. They're roughly a football field long. They use high heat and torque to push a billet of aluminum. The best way to describe a billet I have is a telephone pole. About that same diameter, about that same length, you know. The billets come in all different shapes and sizes as well. Common description, like I said, is a telephone pole. By using heat and pressure, the aluminum is forged as it passes through the die's shape, giving it strength. Aluminum extrusions are used every day by everyone in the developed world, especially. From window frames to missile fins to gun frames and electronics. In every computer there's a heat sink, which is actually an aluminum extrusion. There's things like your ladders. I mean, here's a ruler from Man-Made next door that's actually, you know, so they come in all different shapes, as you can see here. I mean, they got specialty ones like this. We got hollow dies, which have a hole in the middle. I think that one was a pole. They just, you use them every day on file cabinets, the railing. I mean, you can just look around and you can just see, you know, everywhere. You really take it for granted, and you don't even realize it. So here's some pictures of them. I remember that one right there is actually a armadillo bottle opener. You all remember that one? Mm-hmm. Bottle opener. Yeah. All right. So here's some pictures of dies as they come in, you know, different shapes and sizes, and obviously. That's the smallest one that I've ever seen, which is itty bitty. I mean, it's like, you know, like an inch and a half. It's up there in my granddad's office. We have 8x1s, anywhere from down to one of those 5 by 3/4 of an inch, all the way up to 11x2s are pretty much our most common. As you can see, the difference in color here. These are pretty hard. These are pretty hard, and these are soft, shiny, and grayish. So the process begins in the back, where we have very large, very heavy, very expensive pieces of steel bars out there. Again, they're cut into bigger dimensions, so they can be turned down on our lathe. This is considered the first step besides actually ordering. We have 2 lathes. We used to have 3. One was a real small one, but we got rid of it. This is our CNC lathe. It's just a picture of it. They put the die on there and it clamps, and it's got teeth here that cut it down to like this right here. I'll put this whole lip on it. Actually, I mean this whole thing was turned, technically. So, very, very interesting process. Then we go to the CNC mills. They use all different kinds of cutters, anything from hogs to high-speed steels to specialty cutters, flutes, drills, you name it. A picture of it in action. That's drilling a backer. And we have 4 CNC Fidel mills.
What's the backer for?
Oh yeah, I forgot about that. Okay, so inside the press, there's a container which holds the die and the backer and the feeder plate. The thing about our business is every single thing, its name is actually what it does. So the feeder plate, I mean, it feeds. You know, the die is the shape. The backer is to reinforce the die.
Go in the back.
Yeah, so feeder plate, which helps feed the aluminum through. The die goes through the shape. The backer is a bigger shape of the same shape, but it's just there to reinforce the tongues and the certain areas that are weak on the die. And then you got the bolster, which is really big and really heavy. I mean, they can get to, I've heard of them, I've never seen them to where they're so big you can actually crawl through them. You know, over in Germany they make up to 4 feet.
4 feet backer?
Yeah.
Bolsters?
Bolsters, yeah. So, I mean, the shapes, you can actually go through them. So we got all that in the press. It's all pinned together and bolted together. They're all heated up. They're preheated to, I think, like 400 or 500 degrees. That way, and so is the billet, the aluminum billet, because if you push a cold billet through, all it's going to do is break that die and everything in half. Literally like this, even though this one was cut in half. So they have to heat everything up, which takes a long time. It takes a few hours probably just to heat up one long billet, So, but yeah, that's the backer. Backers are bigger, bolsters are even bigger.
Como acá, ¿a cuántos grados se tiene que quemar el aluminio para que salga por el heater plate? Oh, how many degrees do you have to heat up the aluminum for it to go through?
I've been told that it's up to 700 degrees. The billet, before they push it. Because like I said, if you push this frío, if you push it cold, I mean it just smash and break and everything, So, but yeah, I mean you think of aluminum and you're like, well, it's very soft, I can bend it and all that. But this used to be about that big and 40 feet long. And then they cut them down, and so it's welded together. Basically, it's forged into that shape. So yeah, it's just like with steel. There's many different kinds of aluminum. There's many different kinds of oils and all kinds of coolant grades, and so you really just got to pick something that you like to work with and go with it. I mean, these are all H2, and this is I think it's 1010, 1010. I think it's 1010 alloy. So the next step is obviously heat treating. We have ground furnace, which handles our nitrogen process. We have a high heat, which runs at 1850. The one next to it is 970, and the one on the far end is a smaller one that we usually run about 320. So here's a picture of the control panel, and these are the pictures of before and after. You can see the different shades, of the steel. So that's very soft, and those are hard.
What's nitrate for?
Nitrogen, we do nitride it's kind of like, say, if you could look, like say in a microscope, you can actually look, well, you may be able to see it on here actually. If you could look at it in a microscope, you'd see that the molecules it's real I don't know how to describe it. I mean, it's like, it gives it so much more strength. Like, it's kind of like a shell that it penetrates all the way, I mean, just a few thousandths deep. But it's just enough to give it that extra strength that it needs to withstand a harder alloy of aluminum. The nitrogen nitride process takes about 8 hours, I think. We run it at 970 with ammonia gas running through it. The actual byproduct is flammable. I didn't know that until we had an incident. So yeah, think of as the heat treating as really penetrating it, and then the nitride just kind of giving it a hard crust, I guess you could say.
And what makes it flammable? The nitrogen?
When the ammonia passes through the water, it loses an atom. So what comes out is like hydrogen, I think. It's a hydrogen gas that comes off.
Oh, yeah, and catches it.
Yeah, so we have a big tank out back. It's got the vent coming out of it. Well, Worm, Dwayne, accidentally lit it up with a lighter one time just to see that in there. And it went whoosh, like this big old flame. So, because I mean, obviously ammonia is not flammable. So neither is nitrogen. But hydrogen is very flammable. So, all right, the next process is the grinding process. We have 2 grinders, big Blanchard grinders. I don't know the exact dimension of the spindle wheel on this one. It's got to be at least 1.5 feet, maybe 2 feet. And it's what we grind them down. We have to grind them down to certain diameters this way, so they can fit inside the container. And then the backer and the bolster, it's just kind of like a step motion. They get bigger as you go back.
And it's a right dimension.
Yeah, down to the almost exact decimal point. And then in this kind of business, we usually have a little bit of play, plus or minus 5 thousandths of an inch. So it gives them that shiny face, a nice flat, smooth. And the next process is wire EDM, my favorite machines. It's really hard to describe this kind of machine without actually showing it to you. But as you can see right here, I actually have a piece of the wire. The wire is 10 thousandths. Human hair is 4. So that just gives you a little bit of a,
Human hair is 4 thousandths.
4 thousandths. Well, on the head. Yeah.
On the head. That one is 10,000.
10 thousandths. 10 thousandths wire. I'm sorry for the technical difficulties we got here. We'll continue with what we actually do with the wire machines. The wire is just a little bit bigger than human hair, like I mentioned. We own Sodicol machines, which is a company out of Japan. It's one of the cheaper models of wire EDM machines, but we've had really good luck with them. The next process, which is I consider as step 7, is bag burning, which, as you can see on the back of this, the actual difference between this is the face of the die, and this is the back. Bag burning only gives clearance. Bag burning's main goal is to give bearings, which is this part right here. This is the only part on the die that actually touches the aluminum. And there's different types of, there's different heights, different levels, because certain places on the die where the aluminum is coming through, it actually has the ability to run faster. So you give more bearing to slow it down a little bit more as it's running. So, we use graphite, as you can see. The tank fills up with oil, and it uses electric discharge, which is what EDM stands for, electric discharge machine. We have a sucker machine that actually sucks the toxic fumes off of the machine as it works. Here's some pictures of you can actually see the bearings down inside there. And the final step is finish file, which finish file just means They use many different kinds of tools, whether it's bar guns, carbide burr guns, diamond coated files, or different grades of sandpaper, and they actually by hand go in and make sure that this surface right here, the actual surface of the shape, is completely smooth and polished. Because if there's any defects or lines or anything in there, it'll actually show up on the aluminum. I don't know if y'all can actually see here, but you can actually see the lines. Like, I mean, it can't be 100% perfect. I mean, doing just what's by hand, and it also depends on how our customers treat our product. You know, if they don't take care of them, they're going to run into troubles and problems. So these dies right here are actually ready to ship out. They've already been heat treated. They've already been nitrided. They've already been completely filed, and all they're waiting on is to be delivered. So if y'all have any other questions, I appreciate y'all's time. Thank you.